Hello everyone, this is PM Chalapalli here. Today we will be exploring this problem in the concept of Lagrange's linear equation. The first thing is to determine whether the given problems follows Lagrange's linear equation structure or not. Okay, this is the standard Lagrange's linear equation form. So here we are going to check our differential equation is following this pattern or not. So we are checking. So this means that we should have capital P and small p, capital Q and small q. So capital P, Q is nothing but the coefficient of small p is your capital P. The coefficient of small q is going to be your capital Q. Then obviously it is going to be capital R. So this differential equation is exactly following the Lagrange's linear equation pattern. So once you confirm that the given equation is following the Lagrange's linear equation pattern, then you can start solving this problem. The first step you have to, the next step you have to write what is P, what is Q and what is R that you have identified in your differential equation. You just write here. After writing this, you have to write the auxiliary equation of the Lagrange's linear equation, which is nothing but dx by P is equal to dy by Q is equal to dz by R. After writing this auxiliary equation, you have to replace this P, Q, R by its actual value. So this is P, this is Q and this is R. So I'm going to replace this P, Q, R by this actual values. After replacing, this equation becomes this one. Okay. From this current Lagrange's, from this auxiliary equation, we are going to find out the general solution. For that, already I have said there are two ways that you can choose to find the general solution. The first way, grouping method. In the second way, multiplier method. Suppose if we go with grouping method, then you should be ready to integrate your given expression. So if you feel to integrate this is difficult, right? Then you can go with multiplier method. So I think that this is very easy to integrate. So that's why I'm just going to choose a grouping method. Grouping method is nothing but we are going to separate this equation, actually equation pairwise. So the first 1 and 2, this is the first pair. 2 and 3 is the second pair. Then you can pair 1 and 3 also. So you can take any pair. So I just have taken 1 and 2. You just write what is 1 and what is 2. Okay, if there is any common term that you can cancel, here Z and Z is common that I have cancelled. Okay, now write the remaining part. I have multiplied, cross multiplied. So this becomes x square, this becomes y square. I just have written here. Now as usual that we have seen in previous problem, here we are going to integrate this expression on both sides. So when you are integrating on both sides, you have to write the integrating simple. After writing this, then you start integrating. So here you will get x cube is divided by 3, which is equal to y cube divided by 3 plus constant 1. So constant 1 is our first solution, right? So that we have already discussed. So let's move to find the second solution. For this, again, you have to take another pair. So this time I'm going to take 2 and 3, right? So this is 2. So 2 and 3. This is 2 and 3. So I just have written 2 and 3 here. The same thing what you have followed here. Here also you are going to follow, right? So what we have followed here, we have integrated first. So I'm going to before you are going to integrate, is there any common term to be cancelled? You can cancel, or you can take cross multiplication. That means you have to write the given expression in the simplest form. So this is the simplest form where I'm going to take integration. So after taking integration, this equation becomes y cube divided by 3 is equal to x is constant here because we are integrating with respect to z. That means we have to integrate only with respect to z. So other variable has to be treated as constant, right? So as per this concept, I just have integrated it. So the answer is x z square is divided by 2 plus constant 2. So I need what? I need constant 2 here. So for that, I'm just going to transform this term to this side. So I just have transform. So when you transform, your sign will be changed. So here we have plus, so it is minus, right? So this is my C2. What is general solution of Lagrange's linear equation? Which is nothing but pi of u comma v is equal to 0 is our general solution for this Lagrange's linear equation. You just write that general solution formula. After that, you have to replace u and v by its value. Okay, u and v is nothing but C1, that means constant 1 and constant 2 is going to be played here, u and v, right? So you have C1, you have C2, you're going to write your u and v. So after writing, this is your general solution of this given problem. Okay, so thank you so much. We will meet you in next video.